The aim of this video is to move rapidly through the November 2010 non-calculator Module 5 AQA paper to bring out the key points which arise. So here goes. Question 1 was a spot the odd one out question. And in one part A there were 3 equations. In the first one, x equals 8 because 8 plus 4 is 12. In the second one, if we add the 5 across, x must equal 18 because 18 take away 5 is 13. In the third one, x must also equal 8 because 4 times 8 equals 32. So this one here is the odd one out because in the other two, x is equal to 8. In part B, there are 4 words. Now, circumference is a distance around a circle, given by 2 pi r, or pi times d. Perimeter is a distance around a shape, also a length. The height is how tall a shape is, that's also a length. So these 3 here are all lengths. However, volume denotes how much 3D space an object takes up. So it's the odd one out. All the other 3 are lengths. Volume measures the amount of space an object uses up. And in part C, these words all link to circles. As a reminder, a sector is a piece of cake. It's a 2D object. An arc is a distance around a curved length. A chord is a line which cuts through a circle. And a diameter is a line which cuts through the centre of a circle. Chord is a line. Diameter, a line. An arc is a curved line. A sector is actually an area. So the sector is the odd one out. On question 2, we were given an object. And we're asked to say which of these were the plan view, side view, or front view of the shape. Now, the plan view is looking down from above, and it's got the 4 squares on top with 1 jutting out. So B is quite clearly the plan view. Now, the front elevation, we can see the 4 front squares, which you could see from the front, with 1 coming up from above as well. So D represents this front elevation. For the side elevation, we would see this front square and the one to the left, with this one here jutting out above this one here. So it forms a sort of an L shape, which is therefore given by E. So that is the side elevation. It also then asked for the surface area. Now, the surface area is basically the total area of the outside of the shape, and it's probably best done by doing a tally. So we've got 1, 2, 3, 4, 5, 6 on the top. Then we've got 1, 2, 3, 4, 5, 6, 7 there. Then we've got 1, 2, 3, 1, 2, 3, like so. Then we've got from the back side we've got 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Then from underneath we've got 1, 2, 3, 4, and 5. 1, 2, 3, 4, and 5. And that covers all the squares of the shape. So the answer is 26. So the surface area is 26 centimetres squared. So reminder, it's a matter of just counting up all the sides and squares of the entire shape. Now, question 3 tests some key vocabulary, absolutely essential. First one is vertically opposite to angle A. Now this is angle A here, The one which is opposite angle A is simply this one here. They are opposite to each other, like so. So angle C is vertically opposite to angle A. Alternate. This can be known as Z angles. Here's angle F. If we imagine a big Z, like so, in the shape, then angle D forms that Z. They're on opposing parts of the line, so angle D is alternate to angle F. Now for corresponding to angle C, this is the angle which is on the same part of the line, so here's angle C, and down here is another angle, and they correspond. They're in the same position on parallel lines. So angle G corresponds to angle C. Now question 4 is about substitution. We're given some expressions down the left hand side with one missing, and we're told to put in 4 and 7 to work out the answer. Now these ones here have been done for us. So the first question is when x equals 7, what does this expression here equal? Well, 3 times x squared, 3 lots of 7 squared, we're told x is 7. Always square first, so 7 squared is 49, and 3 times 49 is 147. So 147 goes in like so. Second one, 6 minus 3x over 2. We're told x equals 4. So x equals 4. Well, 3 times 4 is 12. Divided by 2 is 6. So it becomes 6 take away 6, which equals 0. This one's a funny one. When x is 4, the answer is 9. When x is 7, the answer is 12. What's the rule? Well, the rule is just adding 5. So therefore, the expression is just we add 5 to whatever x is. And the final one, 1 over 3 take away x. X is 4, so 3 take 4. Well, 3 take 4 is minus 1, and 1 divided by minus 1 is minus 1. So minus 1 goes in like so. And question 5, we just got to answer 2 questions linked to this distance time graph. Now Marcus goes on a journey, leaving at 9:30, and gets to Leeds, which is 50 kilometres away. But on the way he stops at a petrol station. Now this flat part here corresponds to when he stopped. So this part must be a petrol station. Now how far has he gone before he stops? Well, we just draw a line across like so. And every small square is 1 kilometre, so 10, 11, 12, 13, 14. He has gone 14 kilometres. He then stops at the petrol station between here and here, which is 1, 2, 3, 4, 5, 6 squares. But that's not 6 minutes, because half an hour is given by 15 small squares. So half an hour equals 15 squares. So each small square must be 2 minutes. So 6 squares must equal 12 minutes. And that's the amount of time he is at the petrol station for. Now, we're not going to answer these questions here. At the top. But I'm going to make reference to this thing here. Now we're given a formula for working out the total petrol cost for 1 year. T equals dA over P. This just means D times A over P. Now suppose D is 30,000. A is 1.10 and P is 15. The total cost will be 30,000 times by 1.10 all divided by 15. Now this can be worked out in various ways. Now to do 1.10 times 30,000 you can either do a big grid method, or 1 times 30,000 is 30,000, 0.1 times 30,000 is 3,000. So the top becomes 33,000 all over 15. And then how many 15s are there in 33,000? Well, 15 in 33,000. 15 in 3 is none. 15 in 33 is 2, remainder 3. 15 in 30 is 2. Remainder 0. 15 in 0 is 0. 15 in 0 is 0. So the answer is 2,200. And that is therefore the price for one entire year. Now, question 6 is a rather tricky question. We're given some wire, which is basically half a circle. And the question is if this bit of wire here was folded into a square, then what would that length there be? So the first question is how much wire is there? Now this wire here is basically half a circumference. Now circumference is given by 2 pi times r, or pi times d. Now we're given d equals to 40. So if this was a full circle, the total circumference would be pi times 40. Now we're told pi is 3.14, so we must work out what 3.14 times 40 is. Now if you're unsure how to do this, then one nice way is to use the grid method. There are obviously many ways of working this out, but in the grid method you put 3.14 across the top and 40 down the side, and put in diagonals like so. And then work out what all these different timesings is. So for example 3 times 4 is 12. Keep on going. 4, 16, these are all 0. Then add up each diagonal, so 0, 6, 5, 2, and 1. And then what happens is the dot literally just plummets down the line and ends up here. And so the answer is 125.60. And that would be the total amount of wire required for a full circle. But this was just half a circle, so therefore we have to halve it. Well, how many 2's go into 125.60? 2's into 1 are 0, carry the 1. 2's in 12, 6. 2's in 5, 2, carry the 1. 2's in 16, 8. And so we get 125.60 divided by 2 equals 62.80 centimetres. So that's the amount of wire. So this length here must be 62.80 centimetres. This wire is then being used to make a square, so the entire square must be 62.80 centimetres. So what's x? Well, there's an x here, an x here, an x here, an x here. So 4 lots of x must equal this answer here. So what does 1x equal? Well, we do 62.80 divided by 4 to get 1 lot of x. Trick to this is to halve it once, which is 31.40, then halve again, which is 15.70. So x equals 15.70 centimetres. Wow, that's a big question. Now, question 7 gets to a bit more routine mathematics. course we know to expand, 4 times x is 4x, 4 times 5 is 20, so the answer is 4x minus 20. Part B, solve an equation. Well, if we take 4x first from both sides, we get 5x plus 7 equals minus 3. If we then take away 7, we get 5x equals minus 3 take 7, minus 10. So then x equals minus 10 over 5, which we know is minus 2. Now, for an inequality, the trick is to solve it in the same sort of way. So if we add 3 to both sides, we get 8x less than 5. Then the simple answer is x is less than 5 over 8. Move on. Indices are quite easy. A few simple rules. First of all, do the number part first. 5 times 3 is 15. Now x4 times x cubed is x to the 7. Just add together the powers. And y squared times y7 is y9. 2 plus 7 is 9. That's the answer. Now for the final one, when we've got over something, then the trick is to times by that denominator. Now we'll put a bracket here, because we have to times up by 3. So we get x plus 20 equals 3 times these two things here. Now 3 times x is just 3x, and 3 times 4 is just 12, so it looks like that. Once again, we times up by the denominator. 3 times x is 3x, 3 times 4 is 12. We're then to solve that like a normal equation. Now I'd be tempted to rewrite this as 3x minus 12 equals x plus 20. I would then take x from both sides to get 2x take away 12 equals 20. I'd then add 12 to each side, so 2x equals 32. And then to finish off, x just equals 32 over 2, which is 16. And that's the answer. Now, by question 8, we're going to sort of get on to some of the harder questions. Question 8 is a standalone one, and it asks for symmetry in a cuboid. Now this just says, if you cut the shape, then could you get the same object on either side? So for example, if I cut the shape like so, with a knife, there would be 2 equal halves on either side. So I can certainly cut it across like that. But I can also cut across like so. If I cut across or cut down, then the same shape appears on both sides. So conversely, I can chop each face twice. So at the top there's 2 ways, the side there are 2 ways, and from that side there are 2 ways, and so therefore there are 6 ways of cutting it, so there are 6 planes of symmetry. Now then, question 9. Simultaneous equations. This actually just boils down to a bit of algebra which we've already solved in the exam so far. Now, these 2 equations involve 2 different variables. However, if we look at the first one, 2y equals x plus 6, we can replace this y by 2x take away 3, because we're told y equals 2x take away 3. So 2 lots of 2x take away 3 equals x plus 6. I can expand this. 4x minus 6 equals x plus 6. Now then, if I take x from both sides, 3x minus 6 equals 6. If I add 6 to both sides, 3x equals 12, so x must equal 4. And then because y equals 2x minus 3, y must equal 2 lots of 4 minus 3, which equals 8, take away 3, which equals 5. And therefore we found the 2 answers, 4 and 5. We're now pushing on some of the trickier questions. Rearranging. Now, the trick here, which is to make x a subject, is to treat this like a normal equation. I want to get x by itself. So I've got y equals this x over w minus t. I'll rewrite this as x over w minus t equals y. So I'm going to add t to both sides. So x over w equals y plus t. And then to get x by itself, I just have to times up by w. So x just equals w lots of y plus t. And there we go. Now for expanding, the best way to access these higher grade skills, I think, is the grid method. Very simple way of doing this. 2x, 3y, x minus y. X times 2x, 2x squared. X times 3y, 3xy. 2x times minus y, minus 2xy. And then minus y times 3y, minus 3y squared. So the answer is 2x squared. Now 3xy take away 2xy is just 1xy minus 3y squared. And that's the answer for 3 marks. Now for the final one, it says using this answer or otherwise. Now, if in doubt, just redraw the grid. Well, there's a shortcut to this way. It's almost worth not worrying about the shortcut, because x squared times 2x squared is 2x4, then 3x squared y cubed, then minus 2x squared y cubed, and minus 3y6. So we get 2x4 minus plus 1 lot of x squared y cubed minus 3 lots of y6. And there we go. That's the question finished. Now question 12 is quite a key one. Now these two shapes are similar, because if we observe, to get from this side to that side, we have just times by 3. So the ratio equals 3. Conversely, to go backwards, we divide by 3. So for example, if this side here was 10, that would be 30. If that was 60, that would be 20. Because of this given times divide rule. However, we're told that the area of Q is 54. And the question is, find the area of this. Now the simple way to think would be, just divide by 3. However, there's a different rule for area. Now with sides, we times by 3 or divide by 3. With area, we either times by 3 squared, which is times it by 9, or conversely, divide by 3 squared, which is divided by 9. So it's not just a ratio. For area, it's the ratio squared. So for area, the ratio is actually 3 squared, which is 9. So because that was 54 centimetres squared, we divide by 9. So the answer is 6 centimetres squared. And there we go.